January 1997. So a boy's pulling a go-kart up a slope, horizontal, constant resistance, moving at a constant speed. Important thing to remember about that is it means that all the forces are in equilibrium. The boy is exerting a force of 250 and we have to find Q. So the first thing I'm going to do is resolve my forces and draw a force diagram. They've started the force diagram for us in the question, and I'm going to add the weight of the cart, and that gives me 40G acting down. There has to be a reaction force, and that's perpendicular to the slope. Once I have this diagram drawn, I'm going to redraw it, but this time I'm going to resolve the forces along the slope and perpendicular to the slope. R and Q are easy, they can go straight on. The weight is always sine component down the slope, cos component into plane. And if you look at the 250, the slope is adjacent, so we're going to use cos 250 cos 30, which means that there must be a 250 sine 30 component acting up the slope. As I said, we're in equilibrium. That means that forces are equal and opposite. So 250 sine 30, which is 125 in my calculator, plus R has to equal 40G cos 30, which tells me that R is 40G cos 30 minus 125. And that gives us 214.48. If I look at up and down the slope, then Q plus 40G sine 30, so that's 20G, has to equal 250 cos 30. So Q will be 250 cos 30 minus 20G, which gives us a value of 20.506. We were asked to find Q, so I need to round this to 3 SF, so that's 20.5 newtons. Tow rope brakes. So we have a new diagram. We are going to have the constant resistance Q, which was 20.506. We're going to have a new reaction, and we're going to have 40G acting down. So there's nothing acting to pull it up the plane. It's going to start moving with a speed of 1. We want to work out when it stops moving. Its acceleration, I don't know, I'm going to have to work out. The question tells me I'm looking to find distance S. So I need to use my force diagram to find A. So if we redraw it now, again with the resolve components down the plane, that's Q plus 40G sine 30, then I can say that the resultant force in the direction of motion is minus 20.506 plus my 40G sine 30, 20G, has to equal mass, which is 40, times acceleration. So the acceleration is the left-hand side divided by 40. And that gives an acceleration of minus 5.4126. So I have minus 5.4126, and it now becomes an equations of motion question. To work out the distance, I'm going to need an equation with u, v, a and s. So I'm going to use v squared minus u squared equals 2as. V squared is 0, so I have minus 1 squared equals 2 times minus 5.4126 times s. So s will be 1 divided by 2 times 5.4126 because the 2 minus signs will cancel. And that gives 0.09237. That would be meters. So that would be 9.24 centimeters, and that is the 3 significant figures.